Here we're talking about experiments for evaluation research. There are only a few experiments in current sociological research, especially in the traditional idea, as we saw with the Milgram experiments earlier in the semester. And we'll talk a little bit about the Zimbardo prison experiments today. Sociologists have often been interested in how people respond to their natural environments, which is hard to emulate under experimental conditions. We're often interested as sociologists in very complex phenomena that often interest you, but introduce too many variables to measure really in a single experiment. Sociological theories are therefore difficult to test experimentally. And after the Zimbardo and Milgram experiments, where there were worries about the ethics of putting people into danger, stress, sociologists have often been reluctant to deceive research participants, which increases the possibility of harm, and so there's been a reluctance there. The reason, though, classical experiments were attractive is the search for causality. Not just seeing that there's a correlation where you see one thing existing in a survey, people tend to believe another, where you don't really know which causes which. The advantage of an experiment is you're often trying to identify the thing, the independent variable, that affects or causes another thing, the classic Durkheimian social fact that is causing the change in the environment. And the advantage of an experiment is you can change that one variable while everything else is held similar, it's tightly controlled. Now, there are a few ways to do a sociological experiment. You can take a measurement of the dependent variable, the thing that you're interested in, and see how it exists before or after you introduce the independent variable. You say, okay, this is where things are now, introduce the change, and see if there's been a change in the reality afterwards. The other classic way is to have a control group. You have people who are similar, you divide the group in two, you introduce the experimental treatment, as it's called, to the control group, don't apply it to the other group, and see if there's a change in the control group that's definable compared to the group that actually has the treatment. Now, and we're going to talk more about those because those are the ways that experiments are usually done now, often in the policy realm. The classical experiment, the Milgram type experiment, what's sometimes called the true experiment, is you literally have a laboratory. So any changes are isolated from outside influences, and so you can monitor and control everything that's happened. The control group and non-control group type policy experiments are still done. These classical experiments are far less common. With evaluation research, what we're talking about that often happens with policy changes, what you have is a treatment, usually a new program, a curriculum in school, a policy introduced, or some way of accomplishing a goal, say in the workplace. And the purpose of the research is to assess how well that treatment works, as well as the effects it has on the organization's clients. For example, if you introduce a new drug rehab program, you want to know whether it's going to be effective. A new curriculum in school, will kids learn more? Because such research usually takes place in real life and not in the laboratory, it often doesn't meet all of the criterion of classical experiments. But still, and here's where there's the practical advantage of doing some of these experiments. If you're seeking to get money, whether from the government, a foundation, or whoever it is, agencies want to know, are they funding a change that's actually going to work? What's often called evidence-based effectiveness. Now, when we talk about methodology, like the theory of what will be, measured as a success in a sociological work, experimental research is nearly always quantitative. usually conducted using what we've called positivist methodology. You have hypotheses. You conceptualize, operationalize those variables carefully. You assign research participants in ways to eliminate or at least minimize the possibility of bias. The treatment that you're trying to apply, the cause that you're trying to see, will it improve or change things, will be delivered in a planned and controlled way, and that the results of the experiments can be analyzed statistically. It really is hard to meet all of these standards in the real world to avoid other causes or biases, but they do exist. The research questions that are appropriate for these kinds of policy research, these are policy evaluations, you're generally trying to ask what effect a promise, a program, a policy, whatever you're trying to implement will have on a group. The questions you have generally imply some form of causality that if we introduce it, we will get some direct change that correlates with the treatment we're applying. Now, no, it's very hard to identify causality with surveys, with interviews, with anything else, because you can't probe which came first. People may even remember, oh, this happened, and then I did this, but people's memories aren't always perfect on that. What caused the change is often not always clear, even when you ask people, or even often when you ask people. So what you're looking at in an experiment is something where you can look at, when you introduce an independent variable, how will it change the reality? And the one advantage you have in an experiment is you can introduce one independent variable and see multiple dependent variables change. For example, you change curriculum in a school, and you're looking not just, will test scores increase, but will attendance increase or decrease? Will other social factors change? So you can actually look at the whole range of effects from one change in the environment. Now, there are a few different kinds of experimental study design. I touched on them briefly before, but let's go a little bit. For example, you can treat all of the research subjects to the same treatment, forgoing a control group. Often you can't treat people differently, say in a workplace, since it'll cause resentment if different people get different treatment. So instead you are going to introduce a pay increase for everybody, or you're going to create like a snack room or whatever the change is. And you want to say, were people working harder before versus after the change? You're going to measure that dependent variable, for example, how hard people work before and after the policy is introduced. Now, the danger is you're missing an alternative variable that's introduced near the same change in the policy. If you give people a pay hike, but also at the same time, there was, a change in the economy such that people were working hard for fear of losing their job, you might think it was the pay hike, but it was something else happening outside of your control. So you can also subject different treatments to naturally occurring groups. For example, you have a drug rehab program and you have different groups come in and you give one program to one group and one group program to a different group that's there. Now, the danger is that if the forces that lead to the different groups, it may reflect differences that affect how they react to the policy change. For example, if the program that you're introducing is new and you say anybody who wants to can volunteer to be in the program, the fact that people volunteer for the program may be the reason the groups are different. They may appear to be similar. They might be racially just as diverse. They may have the same set of ages. But just the fact that one group volunteered and one didn't may be enough to make the group significantly different. And sometimes if you, for example, introduce policy and one policy is introduced in one state and one policy is introduced in another state, the differences between those states may lead to the differences in results more than the policy itself. So you have to think carefully about how random the distribution really is in naturally occurring groups. You can also at times not even have a pretest, a group, something that you look at before you introduce the policy change. You may only measure the dependent variable after the treatment. This is often done, especially when you're introducing people to new knowledge, because you can't test whether they have the knowledge, because if you test for that, that's kind of giving them the knowledge, and then anything you're going to do is sort of like tainted by that. So you may want to just have not want to have a pretest, so you don't influence how people approach the post-test measurement. But it does still make it harder to fully measure how effective whatever treatment you're doing. Now, the other issue is whatever design you have may have different frequencies of treatment or the timing of whatever post-test measurement for success. Because the sampling challenge in experiments is quite acute because many experiments use volunteers or some kind of convenient sampling that really raises the issue of, is the group in the experiment representative of the general population? Experimental evaluation research often includes, say, all clients of an organization and experiment, either in control or a treatment group, and trying to figure out, is there a random distribution between those groups, is the key issue. When you're doing the sampling, you can ideally do a random distribution, or as much as possible, use matching assignments, making sure that two groups, one the control, one the treatment, are similar on demographics and other characteristics that matter to the study. This is a table, it's in your book, of some of the different approaches to sampling. There's the simple random sample where people are randomly in one group or the other. You can also randomize it to make sure each subject is given a number, and you randomly choose the first number down the list. All ones go into one group, all two go into another group. There's stratified random samples where you divide into groups and then you systematically sample to select a given number of subjects from each group. Say you have all these different sociology sections and you pick one section at random and they're in the group. That's the stratified. There are different ways to do this. The point is, the idea is you want the groups to be matched as much as possible. Now, the ethics of experiments have always been dicey, especially with the sort of classical experiments. Institutional review boards are always particularly careful in evaluating experimental research, often want some kind of informed consent, and deceit is usually not looked well on. And there's often a requirement that you debrief subjects after participation to let them know what went on, any long-term effects of the work. And you want to make sure you're protecting the confidentiality of subjects and that any reporting is in the aggregate in ways that doesn't identify individual participation and who was involved. Now, if it's general policy evaluation research, especially of naturally occurring groups, you often don't need IRB approval. It's only if you're actually recruiting and selecting them within a controlled experiment where this kind of approval is required. But there is always, if it is that kind of approach, that there is voluntary participation. If you're doing experiments looking at, say, prison populations, the issue of people being coerced into participating is quite high. And it is there even in many policy experiments involving social programs, because if you say to somebody on welfare, if you don't participate, you lose your benefits, that's a form of coercion that people worry about. Now, when you're going to do an experiment, how do you prepare for data collection? You're often going to use a questionnaire before, so you'll give people a questionnaire before the experiment and one afterwards to see what's changed. And so you have to finalize this measurement survey. If you're observing people's behavior, you'll need to make sure you have clearly and completely operationalized the behaviors that you're going to be observing so that you are consistent in how you observe people both in the control and in the treatment group. If you want to pilot test your observational strategy, you may want to make sure that you have a clear system of note-taking and develop that so that in the research setting, you know what you're doing, you get agreed upon processes for doing that, and that often means training, making sure, especially if it's not just you, but if you have a set of people observing multiple people or running the program, you want to make sure there's consistency in the training, that those who are administering the treatment are doing so consistently without biasing the study. For the actual data collection, the key goal is you want to ensure quality control throughout the experience, that things are as consistent as possible how you collect any data. One of the key problems is that everybody who start in the program don't drop out midpoint. So avoiding that attrition so that people don't drop out, since if people drop out completely randomly, it may not be a problem, but people often drop out systematically. That those for whom the program isn't working drop out, so you don't measure the failure at the end. So you want to, as much as possible, know who's dropping out and avoid them dropping out if at all possible. You also want to make sure that the control and treatment groups aren't talking to each other, that they're not influencing each other, that people aren't looking over saying, oh, that's happening to you, that's not happening to us, and that affects their understanding of, what is happening to them in that experiment. So avoiding that contamination is also an important part. For the data analysis, you're going to create a code book of some type that includes all the information you're measuring, the possible responses or outcomes, and assign a numerical code for each outcome. You're going to clean the data to make sure there aren't inconsistent results. You're going to make decisions that if somebody didn't respond to a part of the survey, if the people doing the observations weren't completely consistent, how to deal with those, clean up the data so that you can then input the data into the computer or any method you're doing to do statistical calculations of any causal effects. You also want to control for any demographic variables. Like this is the idea of as you do multiple variables, you want to make sure that any effects you see are not just true old versus young, men versus women, but if you control for all of the variables, whatever is true for older Black women, younger white men, whatever group you're talking about, the effect would be the same for each of them. Or if it's not the same, you're accounting for that. The things that may cause changes for one group may not make the same change for another group. That's part of the statistical analysis. You also want to ensure that the data is consistent and that you measured what you intended to measure, that there weren't outside effects that may have impacted your subjects. When you have the results, you're going to present them. For evaluation research, you really want to focus most of all on clearly stated results. What was the independent variable? What was the dependent variable? Did it have a causal impact? And you want to have the statistics interpreted for the reader in an easy to understand way. You want to highlight the implications of these results for continued use of a policy, a program. Does it work? Doesn't it work? Who does it work for? And are there any other effects of the program that people have to worry about? You want to describe the methods used in collecting the data in enough detail that somebody else can replicate the study and understand how it was conducted.